Today we're going to learn about terms. In specific, we're going to learn about terms that are called constants and terms that are called variables. Our learning target is I can identify and define terms, constants, variables, and coefficients. I have out here two sentences. One is a sentence that would be written in English, Big Bob is funny. The other is a sentence that would be written in math, 3x minus 2 plus 7 minus 5x. I'm going to make a little analogy about these two sentences and introduce some vocabulary words we need to know in mathematics. With this sentence, we have some words in English. The words are big, they are Bob, is, and funny. There are different types of words in the English language. There are words that are nouns. There are words that are adjectives that describe things. So if we look at the noun in this sentence, our noun is Bob. It's a type of word. Our adjectives are big, and funny, because they describe what Bob is. So we have a sentence that's made up of words, and it has different types of words, nouns and adjectives. The same thing happens in mathematics. We just don't call them words, nouns, and adjectives. And we actually call our sentences something a little bit different. A mathematical sentence is called an expression, as long as it doesn't have an equal sign. As soon as we introduce equality, we actually call it an equation. So right now we don't have an equal sign, so it is an expression. The expression is made up of different terms. Terms are kind of like words in our English, okay? So our terms are 3x. Let me go ahead and write this out for us so we can see it. Our terms are 3x, it's a positive 3x. Okay, we have a negative 2. We have a positive 7. And we have a negative 5x. All of those are the terms that make up that expression. All right, so there are two types of terms that we need to learn about. The first type of term involves variables. Okay, variables are any term that involves an unknown. We represent variables with letters. Okay, so if I was to ask you what are the variables in this expression, the only variable I have there is x. There happens to be two of them, one right here and one right here. However, it's really important to know what those the numbers, the 3 and the negative 5, have to do with it. Okay, there's another type of variable. It's called a constant. A constant is any number that can stand alone. It's typically added or subtracted in the expression. So let's go ahead. I'm going to use color in order to describe this. I'm going to go ahead and use red to describe my terms that are variables. So this term involves a variable, and this term involves a variable. I'm going to use green to show my constants. So I have a positive 7 and a negative 2. Both of those stand alone in the equation, and they do not have a variable, the variable x associated with them. So let's talk about this variable here, a positive 3x. That actually means that I have 3 positive x's. And this variable right here is a negative 5x, which actually indicates that I have 5 negative x's. If we create some zero pairs, a positive x and a negative x cancel each other out. These ones cancel each other out. These ones cancel each other out because they're zero pairs, so they go away. and I'm only left with 2 negative x's. So I'm going to write negative 2x to indicate that I have 2 negative x's. It's important to know what we call this number that's associated with our variable. Any number that's associated with our variable we actually call a coefficient. Okay? Coefficients tell us how many of the variables we have. It's really important to remember that coefficients make it easier to write all of our variables out. Co, the prefix co, means with, so it goes with the variable. Efficient actually means that it is more efficient to write or easier to write. If my coefficient was 20x, I would actually have to write out 20 x's. Not very efficient use of my time. If you need to note these in any of these vocabulary words down in their definitions, please do so in your toolbox now. So let's talk about expressions. You might have heard that we talk about simplifying expressions. Why do we simplify expressions? So for instance, if I had, let me give us an example here, if I had the expression that didn't involve any letters, 3 plus 5 minus 2. That's an expression. It involves 3 terms. Each of the terms happen to be constants because we know what they are. I could simplify this to 8 minus 2, which only has 2 terms in it, but I could also simplify 8 minus 2 to be just one term, one single constant of 6. So why do we simplify? You might say things like to make the expression easier, to read. You might also say that it makes it simpler. Oh, spelling. There we go. Makes it simpler. It also makes it shorter. Okay. There's one really big reason in mathematics why we simplify. It's really to make it so that we only have one of each type of term. I wonder if I can shorten that. Okay. It's really important that it's one of each type of term. So I had 3 constants here, and I combined them into one constant of 6. So let's talk about how we simplify. We simplify through a process called combining like terms. We can combine x's with x's, y's with y's, x squareds with x squareds. We can combine constants with constants. So we also do something that's called applying the distributive property. The distributive property you probably heard about in 7th grade. What it is when you have some number multiplied by a set of things. Okay? What this says is that we have 3 groups of x minus 2. X minus 2, x minus 2. There's a second group. Here's a third group. And I ask, how many of my variables do I have? I have 3 of them, so it becomes 3x. Can I combine these constants together? What is 3 groups of negative 2? Should be negative 6. So you might have seen people indicate the distributive property as to distribute to both of the terms inside of the parentheses. But I can simplify that to 3x minus 6, where here I had one variable, one constant, and then I had this coefficient that was hanging out front that hadn't been applied to everything. Now I have one variable with its coefficient and one constant that has the coefficient applied to it. So if we combine like terms, we can also apply the distributive property in order to simplify expressions. But our goal is to end up with the smallest number of terms possible. So let's look at this expression. Go ahead and hit pause now, copy it down, and try to do part 1, 2, and 3 listed on the side. I'm going to go ahead and carry on. I'm going to use some colors. Okay, I'm going to use red to circle all of my variables, or my terms that have a variable in them where my variable is x. There's only one of them, because actually, even though there's an x in here, the x squared variable is different than the x variable. I have two different terms involving x squared. I also have one constant. I'm making sure to include the sign with my term because the sign is very important when I combine like terms, because that tells me what integer rules I need to apply. So I also have y as a variable. So those are all the terms. The variables are x, y, and x squared. The constants, there's only one. It's a positive 7. So let's talk about the coefficient involved in, sorry about that. The coefficient involved in this term. The coefficient is -2. The variable is x. In this term right here, the coefficient is +3 and the variable is y. In this term right here, the coefficient is 1/2. The variable is y. In this one, coefficient is -2. Our variable is x squared. +4, x squared again. So now I can combine just using my integer rules. What is a -2 plus 4? It is a +2 x squared. I took those two terms and rewrote them as 1. Same thing here. I got 2 y's. I can rewrite it as a +3 1/2 y. For my x variable, I can't combine it with anything because it's the only one of its kind, so I get -2x. Notice that I kept the sign what I got when I combined my coefficients. I kept the sign, and now I read this expression as follows. -2x plus 3.5 y plus 2x squared. I've simplified 6 terms to become 3. I only need to add in that +7 because I don't have any other constants to combine it with, so it stays all by itself. One more thing we need to discuss. It is what happens when we have x divided by 3. Is there a coefficient involved in there? There is. It's kind of interesting. Every variable has a little imaginary 1. This is 1 times x divided by 3. I can rewrite that as 1/3 times x. Let's explore that real quick in a real problem. 12 divided by the 3 is 4. What if I took 12 and I multiplied it by 1/3 like I just suggested? I'd give a denominator 1 and I'd multiply straight across. 12 times 1 is 12. 1 times 3 is 3. And I end up with the same thing that I got up there. 12 divided by 3. So multiplying by 1/3 and dividing by 3 are the same. What if I had this? What would be my coefficient? If you said 2/3, you're correct. That really is 2 divided by 3 times x, or 2/3 x. Hopefully today you learned about terms. There are 2 types of terms, constants and variables. You learned about what variables are and what a coefficient of a variable is. Also, hopefully you learned about what happens when your coefficient isn't always visible. You also learned how to combine like terms and apply the distributive property.